Right, this lesson is about algebraic division. Grade D students will be able to divide a cubic function by a linear function. Grade C students will be able to divide any polynomial by a linear function. And grade A students will be able to use algebraic division in all possible cases. Algebraic division, page 3 of the C2 booklet. Algebraic division uses the process of long division. However, it may be that you have never done the proper long division technique, as it has long been missed out in primary school techniques of division. So let's apply it here to algebraic division. So we want to divide x cubed plus 2x squared minus 17x plus 6 by x minus 3. So we draw our normal bus stop structure. Right, so first of all we look at the highest powers of our function and our divisor. So we've got x and x cubed. Now we multiply x by x squared to get x cubed. So we put x squared in the quotient being what goes at the top. Now that's only part of the answer, so what we do next is we multiply that x squared by the x minus 3 and put it underneath the original function. So x times x squared is x cubed. X squared times minus 3 is minus 3x squared. So far if we multiply our quotient by a divisor, we get x cubed minus 3x squared, which makes part of the original function. Now what we need to know is how much of the original function we still need to get. So we subtract these two to see what's left over. So x cubed minus x cubed is 0, which cancels. 2x squared minus 3x squared is 5x squared. Do be careful about double negatives. So minus and minus is a plus. So we end up with 5x squared minus 17x plus 6. And then we repeat the process again. So we're looking at what we multiply x by to get 5x squared. In this case, it's plus 5x. And then we take that 5x, we multiply by the x minus 3, and we put it underneath. So 5x times x is 5x squared. Five x times minus 3 is minus 15x. We then subtract again, because we've got another chunk of the original function. So 5x squared minus 5x squared cancels. Minus 17x minus 15x, double minus again, means we add. So we end up with minus 2x. Plus 6. Start the process again. What do we multiply x by to get minus 2x? That's minus 2. Minus 2 times x is minus 2x. Minus 2 times minus 3 is plus 6. When we take away this time, we end up with 0, and that 0 is our remainder. And what we end up at the top of the bus stop is the quotient. So basically, x cubed plus 2x squared minus 17x plus 6 divided by x minus 3 is equal to x squared plus 5x minus 2, remainder 0. A second example. We're dividing 6x cubed plus 28x squared minus 7x plus 15 by x plus 5. So same setup. we go through the same process again. What do we multiply x by to get 6x cubed? That's 6x squared. That goes in the quotient. 6x squared times x plus 5 is 6x cubed plus 30x squared. Subtracting, 6x cubed minus 6x cubed cancels. 28x squared minus 30x squared is minus 2x squared. The other terms just get carried down. X, what do we multiply x by to get minus 2x squared? That's minus 2x. Minus 2x times x is minus 2x squared. Minus 2x times 5 is minus 10x. Subtracting, we get 3x. Minus 7x minus minus 10x, double minus again. So we add, we end up with 3x plus 15. What do we multiply x by to get 3x? That's plus 3. Times it again. We get 3x plus 15. Take away, again we get a remainder of 0. So that's two straightforward examples. Now, next example, one complication you get is when the function you're dividing has missing powers of x. Now you have to be careful here in how you but if you structure it properly, it won't work out too differently. So again, the x minus 2 on the outside of the bus stop, we put in x cubed, or at least attempt to. But what we need is an x squared column, so we put in 0x squared, then the minus 3x minus 6. It is possible to do it without the x squared column, as long as you're careful, but this, by putting in the 0x squared, you're less likely to make errors. So what do you multiply x to get x cubed? That's x squared, so it goes in the quotient. X times x squared is x cubed. Minus 2 times x squared is minus 2x squared. So this is why it's useful to have an x squared column, because although it's not in the original function, it does form part of the working. X cubed minus x cubed cancels. 0x squared minus 2x squared is plus 2x squared. And a minus 3x and a minus 6 carry down. What do we multiply x by to get 2x squared? That's plus 2x. Timesing, 2x times x is 2x squared. 2x times minus 2 is minus 4x. Subtracting, minus 3x minus minus 4x is plus x. So we get x minus 6. What do we multiply x by to get x? Well, same thing, so 1, so plus 1 at the top. 1 times x is x. 1 times minus 2 is minus 2. Then subtracting, x minus x is 0. Minus 6 minus minus 2 is plus 2. So we get minus 4. So in this case, our remainder is minus 4. So, whereas with numbers you only get positive remainders, with algebraic division it is possible to get negative remainders. In fact, it is possible to get functions depending on the degree of separation between what you're dividing by and what you are dividing. Final example. So x minus 4 on the outside of the box, and 2x cubed minus 5x squared minus 16x plus 10. What do we multiply x by to get 2x cubed? That's 2x squared. Multiplying through, 2x squared times x is 2x cubed. 2x squared times minus 4 is minus 8x squared. Subtracting, 2x cubed minus 2x cubed cancels. Minus 5x squared minus 8x squared is 3x squared. Carry the other terms down. We'll do multiply x by to get 3x squared. Plus 3x. 3x times x is 3x squared. 3x times minus 4 is minus 12x. Subtracting, minus 16x minus 12x is minus 4x. It's 10. We'll do multiply x by to get minus 4x, minus 4. Minus 4 times x is minus 4x. Minus 4 times minus 4 is plus 16. And subtracting we'll get minus 6. And this concludes that presentation. Oh, well, one last point of course. The point of algebraic division is to help break down polynomials for factorisation, or to break down fractions into partial fractions. Partial fractions is a topic that you'd only see in A2 Maths and C4.